artificial sweeteners have been integrated into human diet with the hope that we would generate this sweet taste without paying the caloric price. However, when we look at the microbiome, these compounds can lead to obesity, to diabetes, and cardiovascular complications.
Dr. Eran Elinav led breakthroughs on the science behind popular sweeteners. He leads the Institute for Microbiome Research at the Weizmann Institute of Science, and his lab is on the cutting edge of gut microbiome research.
I think the biggest misconception is artificial sweeteners do not lead to weight gain. However, a very big eureka moment for us, we had a whole group of individuals consuming these sweeteners and were developing a change in their blood sugar control, which is exceedingly important as a contributor to metabolic complications.
We're also joined today by Tim Spector. Tim is one of the world's top 100 most cited scientists, a professor of epidemiology, and my scientific co-founder at Zoe.
You've got the aspartames, the sucraloses, which is called Splenda in most countries. You often now see 3 or 4 sweeteners together with sugar in the same product. If you feed our microbes anything a bit weird, there's a chance they're going to react in a weird way themselves, and then making them secrete other chemicals that might have effect on our brain or our metabolism. So that's why we've got to be very careful about what we're eating.
Stevia comes from a plant. Does that mean it's good for us? Welcome to Zoe, Science and Nutrition, where world-leading scientists explain how their research can improve your health. Eran, thank you very much for joining me today.
It's a pleasure to be with you guys.
We have a tradition here at Zoe, Eran, where we always start with a quick-fire round of questions from our listeners. It's designed to be incredibly difficult for professors because we have these very strict rules. You can say yes or no, or if you absolutely have to, you can give us a one-sentence answer. Are you willing to give it a go?
Yes, I hope I can comply with your strict rules.
Well, let's see. Eran, are artificial sweeteners healthier than sugar?
Not sure.
Well, I told you it's tricky. Could some artificial sweeteners be harming our gut microbiome?
Well, they definitely change our microbiome in ways which could be harmful in some cases.
Tim, stevia comes from a plant. Does that mean it's good for us?
No, so does hemlock.
Sorry, that's making me laugh so much I can't move on. Tim, could eating artificial sweeteners make you crave sugar?
It's possible.
Wonderful. All right. And then final question. You get a whole sentence on this one, Eran. And after this, you can then have paragraphs. What do you think is the biggest misconception around artificial sweeteners?
I think the biggest misconception is that artificial sweeteners are inert to the human body.
I actually think that's a brilliant introduction because until a couple of years ago, I absolutely thought artificial sweeteners were completely inert to the human body. I'm incredibly excited to have you, Eran, on this show because there are almost no randomized controlled trials published about sweeteners on human beings, except for yours, published in the world-leading journals, Nature and Cell. So we've definitely, have this opportunity to speak to, really the top researcher in the topic. Before we get into that, I'd actually love to ask Tim about this story that he told me that made me start to think that maybe artificial sweeteners weren't this thing that I'd always been told. And I remember, Tim, that you told me this story about an experiment you did on yourself. Could you share that story perhaps with all of us?
Yeah, I mean, as you know, Jonathan, from my books, I often do a bit of self-experimentation and doing things like the French cheese diet or giving my son the McDonald's diet. And I was really interested in this idea that artificial sweeteners were totally harmless and that these chemicals just pass through us, just tickling our taste receptors and nothing else. And they couldn't possibly affect our metabolism, because that's the story the drinks industry was telling us, really. And so I took a big dose of several sweeteners, and I tried initially aspartame. Then I started wearing a glucose monitor. So we were in the early days of Zoe. I was we were testing these glucose monitors to see if I got a sugar spike at all by taking a couple of these sachets. And I didn't get anything with aspartame, but then I changed to sucralose, which I think is called Splenda in most countries, and did this 3 times. And 2 out of the 3, I got a significant sugar spike. So my glucose level actually went up. Not as much as if I was having a whole, a can of Coke or Pepsi, but a significant deviation, and then it went back to normal again. And I did one of these in a metabolic chamber, so I knew there was nothing else going on because it was very boring in there. There was nothing to do, or I couldn't exercise or anything else. So I knew it probably had to be the sucralose that was doing this. And that's when I realized that these were absolutely not inert, and that certainly some people, and I put myself with them, are some of the people that responded to it. And I did give it to some of my other colleagues at work, and some reacted and some didn't. And we did a few experiments on twins as well, and it was clear that there wasn't a consistent response to the sucralose. And sucralose is the one that isn't absorbed early on in the gut; it stays in the gut all the way down, and so you could actually pick it up in the stool. So that was really my first dabble into the science of these artificial sweeteners, realizing that A, they're different, and B, some people do react to them and will trigger their sugar, and therefore, although I didn't measure it, it would be triggering my insulin levels as well. And that really made me worry that we'd been misled for all these years into thinking they were totally inert and that they were doing something to our body, and we should definitely find out more.
As someone running a company that does a lot of data science, here's something that fascinates me. YouTube tells me that 69.3% of you who watch this channel frequently haven't yet hit the subscribe button. So I want to ask you a quick favor. Your choosing to subscribe helps us a lot. It helps us make the show better, access world-leading experts, and ultimately make more progress on our mission to improve the health of millions. So if you enjoy this show, all I ask is that you hit the subscribe button. And in return, I promise we'll continue to make the show better and better each week. Eran, could you come in here and help us to understand, maybe just right at the beginning, like what is an artificial sweetener? Why do they exist?
Yeah. So artificial sweeteners, which are currently retermed non-nutritive sweeteners, are a very diverse group of chemicals that feature a very intense sweet taste. In other words, they are much better than natural sugar in engaging and inducing taste receptors, which lead to our brain interpreting their taste as intensely sweet. So there are hundreds of times sweeter than natural sugar. And these artificial compounds were developed and discovered over a century ago as means of satisfying people's sweet tooth without paying the caloric price. So I think the first of these compounds was saccharin, which was discovered over 100 years ago, and it was used as a inexpensive and intensely sweet substitute to sugar. These compounds have been extensively integrated into human diet with the hope and belief that we would generate this pleasurable, intense sweet taste to many of our foods. So these compounds can be found both as an independent additives to to coffee and so on and so forth. But also, if you were to go to your local supermarket and look at the ingredient list of many foods, you would find these compounds integrated in many cases without explicitly telling the consumers that they're there. So it's actually very hard and very difficult to and it was one of our biggest challenges to find individuals who are not exposed to these compounds in their daily lives.
And there's a huge range of them on there. So, I mean, just probably worth giving people a quick list of as well as saccharin, which was one of the early ones, which came, I think, from the petroleum industry. A lot of these come from basic organic chemistry rather than as foods originally, and are discovered by accident. Then you've got the aspartames, the sucraloses, the ACE-Ks, all the sugar alcohols, things like xylitol. Also, some newer ones, things like monk fruit, neotame. There's an increasing list of these that are often used in combination now, even with sugar. So that's why it's very hard for people to work out what they're eating, is because they're often mixed up now, and it's very hard to separate them.
And Iran, what are the benefits of these artificial sweeteners? Why are people putting them into the foods that we eat?
Well, I think it's very clear and overwhelmingly proven that sugar has detrimental effects on our health. This goes without question, and this is an epidemic that we've been developing as a species, as the human species, mainly since the beginning of the Industrial Revolution. The humans have dramatically enhanced their daily consumption of sugar, integrated it into many of our foods. And this is not the only contributor to the obesity and diabetes pandemic that we're experiencing as a species, but it is definitely one of the major causes to the quite astonishing rise in these metabolic diseases that we've experienced in the last century or so. Now, with the realization that sugar is so unhealthy for us, and on the other hand, the realization that humans love sweet taste, and increasingly so, people have searched for solutions that would satisfy the sweet tooth without having to pay the detrimental caloric sugary prices. And in that sense came these compounds that have been hoped and believed to generate a sweet taste, although with an aftertaste, while not having us pay this detrimental caloric price.
And Iran, I just want to clarify, when you say pay the caloric price, could you explain what you mean?
Yes. Um, uh, it has been believed and actually also very well documented that the vast majority of these artificial compounds, these artificial sweeteners, are not digested and metabolized by the human body or by the human cells in our body. And therefore, since they're not broken down, they do not generate energy or calories that would ultimately lead to weight gain, potentially to diabetes and other metabolic complications. So this part of the equation, I think, is inherently true. And this is the reason why we hoped and believed that a consumption of these compounds would not contribute to the metabolic epidemic. However, one thing that we've discovered, and I think is very interesting and also potentially very important, is that when we look at the human body, we always concentrate on the human cells of the human body. But until relatively recently, we did not consider the vast populations of microbes that live within our body from the moment we are born until the moment we die, which we collectively term the microbiome, as an integral part of the human body. Now, when we look at the microbes in contrast to the human cells, what we've discovered is that in many cases, the microbes, which are much better metabolic factors than our human cells, are able to react, to degrade, and to alter their behavior upon exposure to these seemingly inert artificial sweeteners. In other words, the human body is probably directly inert to these compounds, but when considering the entirety of our body, including the vast majority of microbial cells that are part of us, I think it is also safe to say that in many cases, we are reacting to these compounds in ways which in some cases can lead to obesity, to diabetes, and to their long-term complications.
I just remember my grandmother, who had type 2 diabetes, was taking saccharin, and she was told by her doctor that this was going to help the diabetes in a way and allow her to have her sweet things and satisfy her sweet tooth. And Um, that was one of the early reasons, Jonathan, that people used these sweeteners when they first came out, because they were also more expensive initially when they came out. They weren't as cheap as they are now. I think the other big reason that they've crept in is tooth decay, because in a way that's the one proven benefit of these sweeteners, is that they do reduce tooth decay, which is caused by microbes in the mouth reacting with the sugars to produce certain chemicals, which then erodes the teeth. So, without those sugars, the microbes really don't do any great harm to our teeth. So, that's you know we're probably going to be a bit mean about sweeteners, but we ought to be honest and say, well, dentists do like them, and for good
Oh,
reason.
I love that. So the dentists listening to this are all like, how dare you start saying anything bad about sweeteners? They're fantastic for your teeth. We're now going to look at the rest of the body, and the picture is going to be a bit more complicated. Is that what you're
Yeah,
saying? So,
exactly. Yeah.
Iran, how long have you been studying artificial sweeteners?
We're originally not artificial sweetener researchers. We are microbiome researchers. We were fortunate to be engaged in the research of the microbiome since probably the beginning of the field in the late first decade of 2000. And one of the findings which struck us was that of the many environmental factors that impact and shape our gut microbial population, I think the most important one is our diet. So increasingly in our early research, we were engaged in trying to understand how different dietary compounds may impact the composition and the functions of our commensal microbes, and by doing so, impact our health. And so artificial sweeteners at the beginning came to us just as an example of a commonly consumed food product or food supplement that generated many, many studies and results in animal models and in humans that were often contradictory to one another. So there was a very big, I would say, fight in the scientific, medical, and layman fields with a lot of contribution from the industry in asking whether artificial sweeteners are indeed beneficial, detrimental, or maybe they don't do anything. And many studies, some of which were of good quality, suggested all of the above. So our idea, our eureka moment was that we want to study the possibility that all of these conflicting results could be driven by individual differences in people's microbiomes. In other words, if you carry a certain fingerprint of microbial composition, maybe your reactivity to some of these artificial compounds would be different than someone else. And this could explain why different people claim different things in response to these seemingly inert compounds. So this was a very naive and very scientifically driven, serendipity driven question that we asked. And the results were so surprising that they basically drew us deeper and deeper into this type of research. And of course, the fact that I was drinking 2 to 3 bottles of Diet Coke a day didn't help in that regard.
Well, that's really interesting because I was thinking about that this morning. That I'm in my late 40s, and when I was growing up, I think there was this huge push to move from what I was brought up to call fat Coke to move to Diet Coke, and the same for all the other sort of sweetened beverages, with the view that these traditional drinks that I drank a lot of as a kid were full of sugar. This was really bad for you. And if you swapped it for these artificial sweeteners, it was just the same as drinking water in terms of like the health benefit, but it tasted really sweet. And, that was a really great way to move away from, the Coke that I'd been drinking. And if I understand rightly, what you're saying is this story uh, hasn't really turned out to be true. This is not the same as water.
Right. And if you look at the many studies, and we have looked at the many studies, in humans and in animal models, spanning from fruit flies to mice and monkeys, you can see that the results are all over the place. And in some instances, the results point towards a beneficial effect of some sweeteners. In others, they point towards a detrimental effect. And in a third group of studies, there is no effect whatsoever. So I think that the conflict that this represented, including the financial implications that were involved here, was not just emotional. It really initiated from a very confusing literature on the matter. So you could pick your opinion based on your favorite studies and disregard the others, but this didn't really generalize to a uniform truth.
As I think back to this story of like why, I was being told I should switch to, the Diet Coke and everyone around me, this was very much driven by weight rather than health. The conversation was, there's all these calories in these drinks that are full of sugar. And if you move to the diet one, suddenly there were no calories. So I think you said you were drinking 3 cans a day. Is that what you said, Eran?
I was drinking more than 3 cans a day. I was talking about
more than 3
yeah,
cans.
yeah.
So that's a lot of calories that you would stop having, right? If you move from the sugar version to the sweetener. And so I remember being told, well, everyone will lose lots of weight if you make this shift. So these were that's why they were called diet drinks at the time. What's the evidence for that? What has the science ended up showing?
You're absolutely right. This is the common belief. This is what I believe. But when you actually look at the literature, you can find conflicting examples of clinical trials, some of which are of high quality, that show such an artificial sweetener induced improvement in health. You can find other studies that are equally of high quality that would show you the opposite or don't show any effect at all. One thing that I think is very important to state here is that sugar is unequivocally unhealthy for our health. So excess sugar is not good for us. And all of this discussion should be emphasizing that we're not promoting the reversal of artificial sweetener consumption towards sugar, because this is for sure something that would make your health worsened. I am not saying in any form or shape that artificial sweeteners, should be reverted into sugar. The question is whether it is possible, and this is what we found, that both may have adverse impacts on our health, and we should avoid them altogether.
What I remember when I was looking at this for one of my books, I was struck by stories like Eran's story about how he went from 3 to 5 Diet Cokes a day. That if he'd swapped regular sodas for those, he should be having 600 to 800 calories less a day. That's like a third of his calorie intake. He should be shedding masses of weight by doing that. And the one thing you see in all these studies is no evidence whatsoever of any big shifts in weight. And when you look at the meta-analysis, which is when I've combined all these studies together, often you can see tiny differences between the groups, less than 0.2 of a kilo difference between these groups, which is not matching at all these calorie differences. So that was really instrumental in me, firstly, doubting the whole calorie question that, calories were the only thing that matters in nutrition. And also that this whole story that the drinks industry had sold us about these diet drinks, because it just didn't happen that way. And so in a way, that for me was my entry to this, why it was so weird that when you looked at the epidemiology, you didn't see these big effects that you would expect if people were suddenly, swapping from regular sodas to diet drinks. In theory, the weight should have poured off them. And that just absolutely didn't happen. And unless you were super slim, Eran, but I'm not sure that was the case. Was that right?
I was far from it. Since I'm situated at the Weizmann Institute of Science in Israel, and we have many world-leading physicists here, in addition to us biologists, one of my physicist friends told me once, if there was an alien coming into Earth and he would look into this matter, he would probably end up with the conclusion that artificial sweeteners promote weight gain, because he would find all of these overweight and obese individuals consuming them very heavily. So really, it's the egg and the chicken question that really intrigued us.
Tim, that's slightly mad, isn't it? That you could switch from taking, you could take 600, 800 calories out of your diet by going from, the full fat Coke to the Diet Coke. And you're saying then when you look at all these studies, you don't have this massive weight loss. Could you just explain for a minute what's going on?
Well, exactly. I mean, the question is, what's not happening? What's not happening is that there's a direct correlation between your calorie intake and your weight loss, so that the body is perhaps compensating in other ways. That was one explanation, which we're increasingly seeing, that either your appetite is potentially ramped up slightly, or your metabolism is altered in subtle ways to compensate for this, or something else is happening to your metabolism that we don't fully understand. Because the studies were done, many of them were quite rigorous studies. There are hundreds of them now, and none of them showed this big effect that you would see if there's a direct correlation between this reduction in calories. But it's sort of similar to the calorie restriction diets that we see, that you do get an initial bit of weight loss, and then the body compensates, and then your weight starts to regain, your appetite increases, day by day, just subtly, and you don't even notice that you're perhaps hungrier than you were. So it's probably a combination of these things, plus, as we're going to go explain, these consequences of what these chemicals are doing, perhaps to our gut microbes, that are then making them secrete other chemicals that might have effect on our brain or our metabolism or our immune system in ways we don't yet fully understand. For me, that was my eureka moment, was this looking at the epidemiology early on before anyone else was really into it, and saying, God, this doesn't make sense. These should absolutely not be called diet drinks, because that's the one thing they don't really do, is help you diet.
It's amazing. Iran, I'd love to switch to your research now. Very few people are actually doing studies on the microbiome in human beings where they're able to really understand specific impact of specific foods. That's obviously something that is really fascinating to me, and I think lots of listeners. Could you tell us, I think you're saying you started with this idea that these artificial sweeteners were inert. They didn't have any impact on us. What has your research shown?
We started in exploring the possible impacts of these compounds, of these sweeteners, in animal models, specifically in mice, which are very controlled settings that we can learn a lot from, that they're not as complex as human beings and as diverse. My graduate student, now an independent researcher in his own right at Hopkins in the US, designed an initial experiment in which he gave high doses of some of these compounds into mice that have never, of course, seen these compounds. And to our astonishment, his results were that these mice were developing a higher tendency to develop disturbances in their blood sugar control. They were kind of leaning towards the development of diabetes. He showed me these results. I did not believe them. Of course, being a skeptic scientist, he repeated them again and again and again. And this was very, very reproducible. And this was the first eureka moment, which told us that something in the body of these mammals, of these mice, was actually reacting to these seemingly inert compounds in ways which could be detrimental to health. And this started a very long journey in which we, at the beginning, mainly focused on one of these compounds, which is called saccharin. It's the granddaddy of all artificial sweeteners. It's actually very popular as a sweetener in Israel, where we performed studies. And we really dove deep into this one compound, tested it in different doses, including doses that are equivalent to the lower doses that humans consume, different mice, different genders, and so on and so forth. In all of these cases, we found that in mice housed in our facility that carry a specific microbiome, the consumption of saccharin was associated with a quite remarkable tendency to develop disturbances in sugar control, to develop diabetes.
You're saying that you took these mice, you were just giving them this artificial sweetener. You weren't giving them any like sugar or doing anything else that was changing their diet. You were just giving this artificial sweetener, which, we've all been told doesn't do anything in our body. It tastes sweet, it goes through. And in these mice, you actually ended up giving them diabetes, which is a disease that I associate with having lots and lots of sugar and other sweet food. Is that right?
Yeah, that's absolutely right. And this occurred in, when we gave these mice different diets. For example, a diet reminiscent of the Western diet, full of fat, or in healthier diets, and this seemed to be at least in our facility. And the question was, since this compound has been known and studied for a century, and we know that the mammalian cells, the mouse cells, and the human cells probably don't digest it, how do the consumption of this compound result in these diabetic effects? And this is where the microbiome came in. And we started looking into the microbiome because this is what we do in life. And we found to our surprise that the microbes were actually reacting to this compound. And we could even induce diabetes by taking the microbes from the guts of mice that were consuming saccharine and transferring just the microbes into mice that have never seen saccharine. These recipient mice developed diabetes, proving that the microbiome was actually driving the effect. This was a very big eureka moment for us, leading to the publication of our findings in Nature in 2014. And as you can imagine, this generated a lot of discussion that spanned outside of the scientific and medical communities. And one must also mention that in this initial study, we've also performed a very small preliminary study in human volunteers who were given saccharine, and we measured their blood sugar controls using continuous glucose monitors, just as Tim has mentioned. And we found that half the people who were exposed to saccharine didn't care at all. They didn't change their blood sugar control. Their blood sugar levels were completely the same. But the other half of these individuals developed marked disturbances in their blood sugar control, even after a week of exposure to this compound. None of the individuals in this small preliminary trial actually improved their blood sugar control. This was a very counterintuitive, but a very important moment in this type of study, because it told us something very fundamental, not only about artificial sweeteners. It told us that, rather than quantifying foods or food components in their ability to induce changes in the human body or in the mouse body in this case, we need to start thinking about how to quantify the recipient, the people who actually consume these compounds. And this goes against the one-size-fits-all dietary paradigm that was prevalent for 50 years before this, and led to the personalized nutrition concept, which was developed. And artificial sweeteners in our hands were the very first example of these personalized microbiome-driven effects that dictate why one person would react to a given food while the other person would not react to the same exact food, even when it's consumed at exactly the same quantities.
It's totally amazing. I just want to check one thing you said, because you were telling this right, I think, incredibly powerful story about what you put together in this paper. I think you said that as part of this study, you discovered that there were particular microbes that you found in the gut of mice that had ended up getting diabetes, and you could take those particular microbes and put them in healthy mice, and those microbes alone gave those mice diabetes?
That's absolutely true, and this is for us a formal proof of causality, of showing that the microbiome was not only associated with a change driven by diet, but it actually was driving at least some of the effect. Because when the mice that received these microbes develop diabetes, they've never seen the artificial sweeteners themselves. They've just seen the microbes which were previously exposed to artificial sweeteners.
And how did that change the way you thought about the microbiome after seeing, those results?
Well, I think in those early days, we and several other groups, such as the group of Jeff Gordon, have realized, using different experiments, different projects, that the human body, which was for 150 years of modern science regarded as this amazing assortment of cells and tissues, kind of what was actually oblivious to a very big chunk, which should be considered as an integral part of this body. And this is the microbiome, this huge population of microbial cells, which are roughly equal to the number of human cells in our body, which have remarkable metabolic capacities and remarkable contributions to many aspects of our health or to our risk of developing many multifactorial and common diseases. This huge chunk of our body, which was very difficult to study for over a century, should be regarded as part of the human body. We now term the human body a holobiont, which is the human part and the microbial part put together and communicate with each other. And once you do that, some of the ground truth that we believed for many decades, for example, that the artificial sweeteners cannot be digested by the human side of this holobiont, are in fact digestible by our microbial part.
I think that another way to put this in context is if you think of our microbiome, Jonathan, as these series of pharmacies that basically they are chemical factories. And when they see something like saccharin or sucralose, which they've never seen before, right? So evolution, they didn't come up. So they can react rather oddly and they can produce all kinds of weird chemicals in response to that. Maybe trying to break it down, trying to eat it, doing whatever they microbes do. And those chemicals, it turns out, when you transplanted them into other animals, can induce diabetes because they're like upsetting our metabolism. And we don't understand all the chemicals in there. We just know that this is part of this process, that you're messing up the pharmacy. You're suddenly throwing something in there that's, all our normal chemicals are going out of kilter. And this is why it leads to these big changes. So I think that's the way to think about it. If you feed our microbes anything a bit weird, there's a chance they're going to react in a weird way themselves, and then could lead to these diseases. So that's why we've got to be very careful about what we're eating.
Getting older, I've realised that what I eat makes a massive difference to my health. Now I'm eating the things that help my body feel great. With Zoe, I've got actual science to guide me, and my test results help tailor my advice. I'm making smarter choices every day, like what to add to my plate. It's like having a nutritionist in my pocket. It's changed everything. I'm living my best life. I'm going to be clubbing with the grandkids. Join me and over 100,000 people transforming their health with Zoe.
It's an amazing story. Eran, will you bring us up to date? Because I know that you've continued your research since then.
Yes. So following the publication of this paper in Nature over a decade ago, as you may imagine, this stirred a very extensive discussion in many different aspects of the scientific community, the medical community, the nutritional community, and the layman audience, including some rather peculiar reactions from the industry. But this stirred lots and lots of follow-up research from many research groups from around the world, and resulted in this almost decade of follow-up research in really a rain of studies basically showing the same thing in diverse models stemming from worms, fruit flies, mice, monkeys, pigs, humans, you name it. The microbiome has been shown to interact and to be non-inert to many of these compounds. And the more diverse the microbiome was of a given species, the more grays or shadows of gray you would find in the reaction. What was really missing, in our view, though, was a really controlled, randomized setup of really testing this in humans in the most stringent manners. So despite the fact that we're not artificial sweetener researcher, but we are microbiome and nutrition microbiome researchers, we set up a follow-up study, this time mainly focusing on humans, which was very rigorous and very well controlled. And just to give you a flavor of how difficult it was to set up this study, what we wanted to include in this study are individuals who are not exposed to artificial sweeteners in their daily natural lives, in order to avoid the possibility that such previous exposure would have already changed the microbiome and would bias our findings. And we planned on recruiting 120 such individuals. And at the end, our very meticulous screening necessitated the screening of over 1,200 individuals to find these 120 individuals who did not get exposed inadvertently to products in their daily nutritional life that including these compounds, just showing you how embedded they are into our culture. So these 120 individuals who do not consume, to the best of our knowledge, any artificial sweeteners, even inadvertently, were very hard to find. But once we've allocated these individuals, we were able to randomize them into groups of consumers of one of four artificial sweeteners that are very popular around the world. These were saccharin, sucralose, aspartame, and stevia, the natural product. As control, we had two groups, one consuming nothing, basically consuming water, and another important control group, which were individuals consuming the very small quantities of sugar that are contained within the packets of artificial sweeteners. Many people don't know this, but since these sweeteners are often accompanied by a bitter aftertaste, the companies put a little bit of glucose, of sugar, to avoid or to ameliorate this taste. So we had a whole group of individuals just consuming the very tiny bits of sugar to make sure that whatever we show is not secondary to this small vehicle sugar exposure. And we followed them up using continuous glucose monitor, them using very frequent microbiome assessments before, during, and after consumption. And to make a long story short, what we found in these randomized controlled trials was exactly what I've described to you in the earlier mouse studies. Some people with some microbiomes were adversely reacting to these four types of compounds in having an altered blood sugar level. In other words, these individuals were consuming these sweeteners and were developing a marked change in their blood sugar control, which was for us a very important proof for the non-inert nature of these compounds. Of course, these four compounds have very different chemistries, so the microbial changes were very different between these groups of individuals. Nonetheless, this person-specific effect was noted in all four groups. And I also must add that not all sweeteners were created equally. In other words, when we look at these sweeteners as a whole group, potentially adverse effects on blood sugar control were more pronounced as a group when people were consuming saccharin or sucralose as compared to those consuming aspartame or stevia. But on an individualized level, we could find people adversely reacting to all four artificial sweeteners. But we didn't stop there. And we went to the same painful drill of proving causality, not just association, by taking the microbiomes from these individuals and transferring them into sterile mice, which we call germ-free mice. These are mice that we house in specialized isolators, and they don't have any microbiomes of their own, but they're very useful in testing the impact of human microbiomes on the mouse setting. And when we did this, we found that we could reproduce the same reactivity of different people consuming the same artificial sweetener in recipient mice. In other words, mice that were transferred with microbes from an individual developing adverse effects to aspartame also developed problems in their blood sugar control as their human donor of microbiome. And collectively, these mouse experiments generated the proof of causality that the human microbiome was at least partially responsible for these individualized effects upon consumption of different artificial sweeteners.
Eran, you've talked a lot about the impact on your blood sugar and potentially like risk of diabetes. Is that the only thing that these artificial sweeteners can do, or can they have an impact on your health and your risk of diseases elsewhere?
Yeah, it's an excellent question. And I need to clarify here that we've chose blood sugar responses as our readout, not because it is necessarily the only effect of the sweeteners. The reasoning for this decision was both technical, because continuous glucose monitors enable us to extensively and non-invasively or minimally invasively study people's blood sugar responses, which was very helpful for us because we use a lot of AI and machine learning in order to interpret the big data that we generate. And the more conceptual reason for the focus on sugar is that blood sugar control is, of course, important in diabetes, but it is also exceedingly important as a contributor to other parts of what we call the metabolic syndrome: obesity, fatty liver, and their chronic and dreaded cardiovascular complications. So for all of these reasons, we've focused on blood sugar control as our main readout, but that doesn't mean that these are necessarily the only artificial sweetener effects. And I can just name one other type of effect, not the only one, which relates to the risk of developing a cardiovascular disease, heart disease, and other groups. For example, the group by Stanley Hazen from the Cleveland Clinic have repeatedly shown that artificial sweeteners may impact the function of platelets, the cells that are responsible for clot formation in our body, and this could lead to adverse manifestations that would impact the risk of developing a heart disease. This is just one other example, and there are many different people performing research that is focused on other aspects of our health. And so by no means is glucose the only readout that is affected here.
Jonathan, the WHO did a big review and meta-analysis, which they reported on last year, that included 283 studies. So there's an enormous body. Most of those studies are not very good, and the evidence is still unclear. And they came up with sort of interesting recommendations. Overall, their recommendation was these products should not be used to lose weight, and they cautioned that it could be harmful to you. And the studies came into two halves. There was a whole series of studies which were short term, like the ones Eran's doing, but with glucose, insulin, etc., and weight loss, usually comparing with sugar or water, and showed only slight differences in weight. So these tiny differences, so often non-significant, but very variable. Some went one way, some went the other way. Overall, rather trivial differences between them. And then they looked at long-term epidemiology studies looking at heart disease, cancer, many other diseases. And most of those ended up showing around a 20% increase in those risks of disease. But the evidence, because they're observational studies, could always be biased. So they're sort of hard to interpret. But there were these two strands. So one saying that short term, they might be slightly better than sugar, but long term, they were causing a suggestion that they were linked to some increases in diseases. So it was it wasn't definitive, but it was still the first official body that came out saying we should be worried about these chemicals.
And Tim, I just want to make sure I've understood that right, because I think I've also heard you both say sugar is really bad. So you're not saying swap artificial sweeteners for sugar, but I think what you're saying is the data is now starting to say something that's completely different from what I was brought up with, which is, wow, not only do artificial sweeteners not help you to lose any weight, which is definitely not the story that I was being told, but you're actually saying there's starting to be evidence that artificial sweeteners can really be negative for your health. So if you were able to take them out of your diet and not replace them with sugar, you would be in a better place?
That's what the data overall is suggesting. Although, to do that, you'd need a proper randomized trial that lasted years, and that hasn't happened. It's very hard to do it. So we have to rely on this imperfect evidence, which are these observational cohort studies. And as Eran's pointed out, some people take these products because they feel they want to lose weight or they want to get healthier, rather than purely as a a sort of pleasure choice. So that's the difference. But I think we're moving to the point where it can't be considered the same as water, definitely. And the WHO's conclusion that it shouldn't be seen like that. There are trivial weight loss advantages. And there's this potential gray area that they might be causing some of these diseases that might well be mediated by our microbiomes that we need to investigate. It's going to vary by person, and it's going to vary by the actual sweeteners themselves. So it's hard to generalize as well, because they all have very, very different actions. As we've discussed, some are, stevia acts very differently to to something like aspartame, for example, or sucralose.
So I would love to switch to actionable advice. Like I think you've painted a picture that I think for a lot of listeners probably blows their mind a bit because it's so different from the story we've heard. And it's amazing around to hear you taking us through like your primary research has done that. I guess the question I start with is, should someone listening to this consume any artificial sweeteners? What's your takeaway, Eran?
This is a very important question, and as you may imagine, I'm being asked this question in many different circumstances, and my very careful answer as both a physician and a scientist is that the jury is still out there in terms of definite proof, and medicine can be imaged as a very heavy ship that takes a lot of data in order to change its tracks. So the jury is still out there. But on the other hand, I think that enough information has been accumulated on the fact that these seemingly inert substances are not really inert, and they may impact our human body. In some cases, of some people with some microbiomes, they may even cause adverse effect. And all of this cumulative data, at least in my personal case, leads me to a recommendation that people would practice a healthy skepticism and caution until we know better. For sure, my recommendation for people is to never consider swapping sweeteners back into sugar. This, for sure, would be a not very smart suggestion because sugar is not good for you. My personal preference is to avoid both of them until we know better, and to drink water as much as possible. And for those who find it impossible, to minimize as much as possible the consumption, so to control for excessive consumption of these compounds. However, we need more information. We need more studies. This field, which really connected the microbiome and these compounds just a decade ago, has now been branching into many different medical and scientific groups exploring it. So data is emerging. As Tim has mentioned, the WHO has already concluded that enough evidence has been gathered to at least put out a general warning against indiscriminate use, especially among populations at risk of developing diabetes and obesity and so on and so forth. Until then, I would recommend the public to stay aware, to learn more and more, and to practice a healthy caution.
Well, I think the one thing, we don't want to petrify people into thinking that if they have, one can of Diet Coke or Pepsi, they're going to get cancer or a heart attack. That's not going to happen. And probably, at the level of one drink a week, really people shouldn't worry. It's people like the early Eran who was drinking 3 to 4 Diet Cokes a day, be more worried about. So that's one thing. So getting it down to reasonable levels. If you really enjoy those drinks, you have them as a treat, but you don't have it as a staple. I think that's a sensible thing. But I think the other big issue here is on hidden chemicals in foods. So you may have some of your favorite cereals, biscuits, cakes, other foods, some ready meals that contain these mixed up with salt and sugar to sort of camouflage it, that you're having on a regular basis. And generally, you should be avoiding those ones. Also, these are a sign that food is being tampered with. It's been made by food chemists. It's fake food that's being is messing with your brain. So you should be highly suspicious of foods that contain it and try and see that as a sign of poor quality and try and move to substances that aren't like that. I think that's what shoppers should be doing, because it's going to be increasingly hard to sort out which of these are bad for you, because there'll be a combination. You often now see 3 or 4 sweeteners together with sugar in the same product, make it really, really tough to ever work out in the future what's there. But you should say, well, why is someone giving me 5 chemicals just to make me like this product? We should be more suspicious about it. But at the same time, don't get obsessed about it, because the occasional use, we would have seen something by now if just having it once a week was causing you major heart attacks or cancer or diabetes. It doesn't do that, and it's certainly better than sugar. But let's get people drink tea again. Let's get them drinking kombucha. Let's give them there are lots of other healthy beverages we should be switching to.
And Tim, so imagine that you're saying that both Coca-Cola and now Diet Coca-Cola is off the table, and same for all the other manufacturers. But there'll be a lot of people saying, well, it's like really hard to switch from that to water because I'm really used to all of these sweet tastes. Do you have like an easy tip for how to transition off those drinks for anyone who's listening?
Most of us have done this when we were kids. I used to anyway, have tea with about 4 spoons of sugar in it when I first started having it. And gradually you just dial it down so that you again go to 3 and then to 2 and then to 1. And I think the same is true with these products. You need to wean yourself off, I think, that amount of sugar. And once you've done that, they're too sweet for me to actually have them now. We do have these thresholds for sweetness that we can manipulate ourselves, and getting used to more bitter tastes and sour tastes, and fermented drinks and things like this are an important way. So I think teas, kombuchas, and diluting down these products gradually to get yourself off them in a few months is probably the way to do it.
I'd love to come back to stevia because our listeners had a lot of questions about it because it's positioned as a natural product. And therefore, they're saying, well, is that fine? And I could put lots of stevia into all of my meals because that's natural and therefore healthy.
It is a leaf in its original form, although the original leaf had a slightly metallic taste to it. So the industry has worked out a way of producing some of the chemical in that leaf artificially through microbes. So they actually make stevia in vast breweries using, I think it's yeast, to do what's called precision fermentation. And they will produce this bioidentical chemical called Reb-M, which gives you the stevia sweetness without that metallic taste. And that's now produced. So you can call that natural or you can call it artificial, depending on your definitions. But that's how it is produced. It's only something better than from the petroleum industry. But I think we need more data on it. And it sounds like it does interfere with our gut microbes, but we don't know whether that's particularly good or bad. I think Eran can perhaps tell us. It disrupts them. And in some people, this might be harmful. In others, it might be fine. We don't really know yet, but we do know that the microbes are interacting with it. So I think the jury's still out on stevia. It's probably better than the other ones, but I don't think we quite know where it fits.
Eran, what are your thoughts on stevia?
Well, first, I would like to say that I fully agree with Tim's interpretation and conclusions on the entire state of the art of where we stand today. And with regard to stevia, indeed, what we found was that upon short-term consumption of doses of stevia that correspond to, at most to medium consumption of ingredients related to stevia, some people with some microbiomes reacted to stevia by worsening their blood sugar control. And this was mediated by the microbiome because similar effects could be reproduced when we took the microbiome from these consumers and transferred them into mice. However, whether this actually would cause a risk of disease and whether this would be present when people consume stevia for a longer period of time is something we still don't know. So the jury is still out there. For sure, such effect would likely be personalized, but we need more information. And I think on a more positive kind of forward-looking note, there is now a very keen and extensive industry-sponsored effort to identify and to test new sweeteners that may or may not be better to our health than the ones that we've tested. The fact that they're natural or not natural to me is irrelevant. As was mentioned before, some of nature's worst toxins are very natural. So that doesn't mean that something is necessarily healthy for you. But the fact that there's now a group effort to identify and to develop new formulations of sweeteners provides hope that we may find such a formulation that would have minimal effects on our microbiome or minimal effects on our body over long-term consumption that would be good to many individuals. We'll see.
And Eran, do you think it's likely that we'll be able to develop this like artificial sweetener that does cause no harm and still like tastes really sweet?
I mean, I don't know. I am skeptical that we would find a formulation that would be totally inert to our microbiome, because our microbiome is so amazing in reacting to everything we throw at it. It's like this amazing biochemical factory that reacts in very strange ways to many different things. But maybe some of these reactions would be minimized or would be healthy or inert in terms of their effect on the human body. We just need to do the experiment and to test these.
Got it. I mean, one of my takeaways from, years of Zoe and these podcasts is that in general, if you seem to only eat things that your great grandparents ate, it feels like it already puts you in a much, much better place than where we generally are. So I don't know any of the science here, but it makes me feel that this is probably not where I want to make my bet. Eran, Tim, thank you very much. I would like to do a quick summary, and I would ask both of you to keep me honest and correct me if I get anything wrong, if that's okay. So I think I start with this sort of bombshell that you don't lose any weight with sweeteners. And so all of those things that say diet on the side of the can, like, don't help you lose any weight, which is, I think, pretty extraordinary.
A tiny amount of weight is possible. So, yeah. But don't expect miracles. That's true.
That then mice can develop diabetes when you put them on sweeteners. So again, the idea that these things are completely inert, they don't do anything, they taste sweet, but have no other effect just isn't true. And then amazingly, you can find the bugs that give them diabetes and put them into another mouse and give that mouse diabetes. So again, like these particular bugs are responsible for this. And as a result of this, we just got to rethink like what these sweeteners are doing. A diet drink is not like drinking water. Adding a sweetener into some food that you buy from the supermarket, that has changed it. Having said all of this, I think you're both really clear that sugar is really bad for our health, that this has caused an epidemic. So no one is saying swap the sweeteners and go back to sugar. And the problem is that human beings are born to love this sweet taste. And so, it's hard to get rid of it. The sweeteners give us that sweet taste. And there is one benefit, which is, if you're a dentist listening, you're saying, well, hang on, sweeteners are great. You don't get tooth decay. What we now understand, though, is that it has this highly personalized effect on us, because every human being has this different microbiome. And depending on the specific bugs that are in your gut, your responses to individual sweeteners will be different. So, Eran, you have this amazing thing you're saying that like one person will respond to saccharin, but another person will respond to stevia. But when you look on average across this, what you see amazingly is that there are lots of people who, when they take these sweeteners, their blood sugar control will actually get worse. And this probably explains, you're saying, why when you look at all the historical scientific studies on sweeteners, they're very confusing. Some say they make you, better. Some say they make you sicker. And probably that's because there is this really personalized response because people's microbiomes are so different. Your studies have focused a lot on diabetes risk, but actually artificial sweeteners could affect sort of risks of heart disease and other things like that. And then when we came on to the end about like what to do, I think one positive message was, don't get terrified. If you're having a can of Diet Coke once a week, don't worry about it. This isn't something you should be so worried about. But if you are having a lot of sweeteners, then figuring out how to take that out of your diet sounds like a good thing. Particularly watch out for a lot of sweeteners that are hidden in your foods, because that's a big change from in the past. It's not just in your drinks, it's in many, many foods. And finally, on stevia, this isn't like a wonder sweetener that solves all of these problems. There absolutely are people where you've seen in these studies that it affects and worsens their blood sugar control. It sounds like it's probably better than some of the others. Depends on your microbiome. But again, I think the main story here is figuring out how to slowly tune this sort of very sweet taste out of your diet allows you to start to take them out completely.
You nailed it.
Very good.
Wonderful. Eran, thank you so much. This was hard to be able to organize. I'm so glad that we could do it. I think the research you're doing is amazing. And I hope we can tempt you back in the future, because I know you're continuing to understand how the microbiome interacts with our food and how this impacts our health. And we would love to have you come back and talk to us again in the future.
Thanks, guys. It's been a pleasure.